Welcome back, everyone. In the last video, we introduced the idea of the indefinite integral, which represents the family of antiderivatives of a particular function. And the indefinite integrals that we talked about mostly pertain to polynomial functions. However, there are plenty of other types of functions in the world, and so in this video, I'm going to go through a few more indefinite integrals. Specifically, we're going to talk about the indefinite integral of exponential functions, trigonometric functions, and inverse trigonometric functions. And I have full confidence you could have come up with all these on your own, but it is nice to have a list so you know what the expectations are. Let's first start with the exponential functions. And our favorite indefinite integral is the indefinite integral of e to the x dx. Because the derivative of e to the x is e to the x, the antiderivative is also e to the x. And so the indefinite integral is e to the x plus c. But what if the base is not e, but some arbitrary constant a? If you recall, the derivative of a to the x was a to the x multiplied by natural log of a. And now that we're going the opposite direction, we're taking the antiderivative. Instead of multiplying by natural log of a, we're going to be dividing by natural log of a. So the indefinite integral of a to the x dx is a to the x divided by natural log of a plus c. And finally, we're going to look at the indefinite integral of 1 over x dx. And is there a function out there that when I take its derivative, I get 1 over x? Well, the answer is yes, that being natural log of x. And while this is not an exponential function, it's a logarithmic function, which is very closely related to exponentials. That's why I put it on this slide. One thing you might notice is that the natural log of x has an absolute value around the x. And this is because the function 1 over x is defined for both positive and negative values, whereas natural log of x is only defined for positive values. And so to make sure that this is not undefined, I need to make sure that I'm only plugging in positive values into natural log of x. And to do that, we put absolute value around the x. Next, let's look at the indefinite integrals of trigonometric functions. And let's start with sine and cosine. And you might remember that the derivative of sine is cosine, and the derivative of cosine is negative sine. And this being the antiderivative, we're going to be reversing that. The indefinite integral of sine is negative cosine, because if I take the derivative of negative cosine, I would get back to sine. And the indefinite integral of cosine is sine, because once again, if I take the derivative of sine, I get cosine. Another common trigonometric function was tangent, and the derivative of tangent was secant squared, and so the indefinite integral of secant squared dx is tangent of x plus c. In the last three you see less commonly, but they still appear from time to time, and these are just reversing all of the derivative rules from earlier on in the term. And the derivative of secant is secant tangent, and so the indefinite integral of secant tangent is secant x plus c. And it's the same thing with the next one. The derivative of cosecant x is negative cotangent cosecant, and so the indefinite integral just goes back the other direction. The indefinite integral of negative cotangent x cosecant x is cosecant x plus c. And finally, the derivative of cotangent of x is negative cosecant squared of x, so the indefinite integral of negative cosecant squared of x is cotangent of x plus c. And finally in this video, I want to remind you of the inverse trigonometric functions. And the derivative of sine inverse of x was 1 over the square root of 1 minus x squared. And so if you have the indefinite integral of 1 divided by the square root of 1 minus x squared, that is sine inverse of x plus c. And just to remind you of some notation, sine inverse of x is the same exact thing as arcsine of x. And for the last rule for this video, the indefinite integral of 1 over 1 plus x squared is tangent inverse of x plus c, because as you guessed it, the derivative of tangent inverse of x is 1 over 1 plus x squared. And I know that I threw a lot of different rules at you in this video, but just like with derivatives, it's going to take practice, but eventually you're going to get it. And keep in mind that you might have to use these in conjunction with the rules from the last video. So if you have a constant multiplied by one of these functions, you would use the constant multiple rule from the last video. You would ignore the constant and take the indefinite integral of the function, and then bring the constant back in at the end.